Hello everyone and welcome back. In this video, Lee is going to be creating the testing framework that was discussed at the end of the last video, along with all of the functionality it will provide us. Lee?
All right, well, I'm going to go in here real quick and I'm going to kill out this line for now because I don't need to write anything out here. And I do want to change this variable to be the I'll just spell it out. The standard random, so standard rand for standard random number generator that we get.
For a second, it was like STD randoms. That was a little concerning, but okay.
Well, I was thinking, STD lib library, and I was going to go that way, but then I was like, no, let's not, especially after that other failed video.
Yeah.
But, all right, what we need to do is set up a constant to begin with. And this will hold our number of iterations that we want to go through for how many numbers we want to generate. So we're going to start off with, let's start 100. Now the meaning of this will change a little bit as we go along, but I'll explain why and when we get to that. Now for our framework, there's a couple of things that I want to be able to keep track of. One is going to be the minimum value that we find. Now I'm going to set this to a double of a value of 1. And then I also want to keep track of our max value. And this will be the double of 0. Now,
Why does that seem so backwards?
Well, think about it. All of our randoms that we're going to be going are going to be in the 0 to 1 domain. Now, if I want to figure out what the minimum value is, I need to compare the number that gets returned from the generator against the last or the minimum known value. So if I start with a minimum value of 0, the min will always be 0 because there's no way that the random number generator can generate a number less than 0.
Mm-hmm.
So I set min to 1, which is the maximum value that the random generator can ever return. And then every time it finds a new number that's less than the min, it's going to set min to be equal to that number.
I gotcha.
And we'll start at 1 and work our way down. Max is the same thing in reverse. So every time a random number returns that's greater than max, which starts at 0, that number becomes the new max and works its way all the way up to 1, which is, again, the theoretical max number. So we put those in starting backwards.
Okay.
Now, I also want to be able to keep a count of how many times a number shows up within the range. Those ranges being 0 to 0.1, 0.1 to 0.2, all the way up to 0.9 to 1. So I need to have basically 10 value counters. So I'm going to create another variable called value counter, and this will be a new integer array, and I'm going to precede it or initialize it with zeros. Let's see, that's 6, 7, 8, 9, 10. So those will be the 10 value counters for each number in the range. I also want to keep a list of all of the numbers that we create because I want to be able to go through and figure out what the average or the mean is, as well as figure out how many duplicates there are. So we're going to create a new dictionary, and the dictionary is going to have a key of a double, and its value will be an integer. The key being the random number itself, the integer being the number of times that that number has shown up in our numbers. Let's see, I need to keep track of the number of duplicates that are found. And I'm going to need to keep track of the number of iterations that we've gone through. Now, like I said, right now we've got count set to 100, so you're thinking, well, what do we need iterations for? Because we already know the count is set to 1. Later on, we're going to put our random number generators into kind of a real world test where our terrain patches are in both negative and positive numbers, and they have an X and Z component, so they're spread out in a grid format. So our array, or sorry, our loop that we're going to be going through, instead of being a loop that goes from 0 to our count, eventually we're going to have nested loops that go from negative count to positive count for both the X and Y or Z. I'll use Y just because it's easier for 2-dimension, but it's actually positional in X and Z space. So our count will literally be 4 times, or the number of iterations will end up being 4 times whatever our count is. So we need to keep track of iterations separately. So that's what that's all about. Actually, it's our count to the power. Is it power 4? 500 times. Yeah, I think it's to the power 4. It works out really strange.
Okay.
Trust me, it's like going, if you type in 100, you get 40,000. If you type in 500, we get 1 million. You type in 1,000, we get 4 million. There's some sort of relationship there, but just trust me for now. The other things that we want to be able to track is going to be our time start. So our time start is going to equal a datetime dot now. We're going to do some stuff here in a little bit. After we do that stuff, we want to be able to figure out how long that's taken, so we're going to have a time stop. And again, that will be datetime.now. And then after that, we're going to do...
Hold on 1 second, Lee. Okay, and we're back from that very quick pause. Apologies, ladies and gentlemen, but it was one of those things that needed to be taken care of. So continue, Lee.
All right, so like I was saying, we're going to have another section for analytics. So let's see. Let's also go ahead and calculate out our elapsed time when we're here. So we'll make another variable called elapsed time. Now to do this, I'm going to create a time span, and I'm going to use from ticks on this one. Now, some of these tests are going to be so fast, we want to have as much accuracy as we can get on these. So we're going to be measuring this in ticks. So we're going to take our time stop, and we're going to subtract our time start from that. And I'm going to get our ticks from there. So that will give a time span calculated based off of ticks. And then we can query out how many minutes, seconds, and milliseconds it took later on with this.
Mm-hmm.
All right, so let's go back up to where we said do stuff, and let's do some stuff. So we're going to start off with a simple for loop to start with. And we're going to go from x0 to our count. We've already got our standard random value up there, so we'll go ahead and rely on that. Going to make another variable called rand, and to fill that, we're going to take standard rand, and we're going to call next double. Not next, next double this time. Get it right the first time. Now that's going to generate us a random number between 0 and 1 and throw it into the random variable. Now I also want to do some work with it, mostly being I want to save it in our dictionary. So I'm going to say do a check, and I'm going to make sure if list does not already contain the key rand, then go ahead and add it. So I wanted to do the check so it doesn't get all upset and throw an exception at us because it's already in the list. So then we're going to add it. So we're going to add rand, and we're also going to, for the value, add the number 1. So this is going to be our 1
Our
count.
very first one. Yeah.
Yep. If it already exists, we need to do some different things. We're going to go and look at our list, find our index or our key of rand, and we're going to increment its value by 1. So if it's already in the list, we're going to take its count and increment it by 1 to indicate that that value has been generated another time.
Right.
We're also going to take all of our duplicate, and I'm going to increment that number. And I meant to make that duplicates, not duplicate. So I'm going to go change the name. So that will give us our duplicates. So basically that's all we're going to do for the do stuff part of it. We're just going to generate some sort of random number, throw it in the list if it doesn't exist, increment its counter if it already exists, and increment the duplicates counter. There is one other thing I forgot to do. We need to take our iterations and increment that number too. Wow, iterations. It's like going, that's not right. So let's go rename this one as well. All right, so we're going to increment our iterations. Now for analytics, there's going to be some more stuff that we need to keep track of here. One is a sum, and this is going to be a double. And I want to loop through each and every item in our list. I'm going to save that as a KVP for key value pair. Create a new variable, call it rand, and this is going to be the key of our key value pair. Next thing I want to do is go and verify if this is not a new min or a new max. So we'll say if rand is less than min, then min equals rand. And we'll check to see if rand is greater than our max. If it is, then max is going to equal our new rand, or our new max will equal rand. So that will take care of our min and max. The next thing we have to do is go and fill in our values. If you remember, we've got this value counter that's got 10 positions for keeping track of the numbers between 0 and 0.1, yada yada, all the way up to 1. So we'll do that now. So we'll check and see if rand is greater than equal to 0 and rand is less than 0.1. Now all the values are in doubles, so we're not using the float notation, as you can see. So if this is the condition value counter, index 0 is going to get incremented, and this is the basis for pretty much the next few lines. So we'll duplicate it. This will be an else if. We'll check that it's greater than or equal to 0.1 but less than 2. And if that's the case, value counter element 1 gets incremented. And we do this 8 more times. So just go through and adjust the numbers.
Just because somebody may be asking this or thinking this, so there's no way we would ever hit 1?
It depends. Some of the variables do hit 1. Some of them do not. We will fix it. I'm just doing
Oh,
the
okay.
quick copy and pasting.
Okay.
I still have to go back and
It's
make
all
another
good.
change as well. Give me a break. I can only do so much at once.
I'm just trying to identify questions that that those that don't have a lot of experience working with code might be curious about. That's all.
Yeah, I just go up and down the list and
I got you.
change numbers. So that takes care of that part. And then this gets changed to be in equals, and I've also got to change that to 0.0.
Cool.
So I had stuff to do.
I'm sorry. Be quiet.
No, that's all right. It's just fun. You always point out the stuff that I know about, but then you decide to be quiet on the stuff I miss.
Well, I don't. I try to tell you that I try to stay quiet for the most part because the last thing we want to do is spark any kind of arguments or anything when we're
Oh, what are you
recording.
talking about?
Yeah,
We never
exactly.
get into that.
So I let you do your thing, but just if there's an area that I think might be confusing to someone out there, then I'm just going to ask you to explain a little bit more. That's all.
That's
So
no
far, you're
problem.
doing great. You're doing great, man. Awesomely. Awesome.
Just cuddling my eagle now.
I'm cuddling your eagle. I didn't know you
Yeah.
had an eagle.
Yeah.
Awesome. I want to come visit.
So I told you that eagle. 1, 2, 3, 4. No, 5. Okay, I better redo that. I can't pronounce words above 4 letters now.
Fair enough.
So, all right. We need to add up our sum. So what we're going to do is we're going to try to get the mean out. So we have to keep track of all the values that we have in there. So we've got to go, our sum is going to be plus equal the value of random. Now, this isn't just as simple as that. We can't just go, all right, that's it. We're just going to take every rand, equal it up, or add it up and add it to our sum and call it good, because we've got values in here that have duplicates. So we could have a value that's, say, 0.8, but 0.8 has a value of 10. So there's actually 10 0.8s. So we have to deal with that as well. So what we'll do is we'll multiply this by the value that is stored at the location of rand, or in the rand element. So if there's only one instance of this number in the list, we're going to just be multiplying by 1 and just adding it, so no big deal. But if the value of the element in the list is 10, then we're going to take, let's say the key was 0.8, so we take 0.8, multiply it by 10, so we get 8, and we're adding 8 to our sum. So this accounts for all of our duplications as well. Now, doing all of the random number generation and doing our analytic calculations is all fine and good and dandy and stuff, but if we don't write this stuff out to the screen, it's not going to do us any good. So let's start writing some stuff out to the screen. So we'll do console, write line. Now, I want to be able to get out the number of iterations. So our first value that we're going to go in is iterations. And I want to keep track of potentially millions of these. So I'm going to format these so I get the nice little comma separations in there. If you're in Norway, I believe, or what is it, the Dutch that use the period instead, or the decimal.
Mm-hmm.
So you can change that up if you want. I don't mind. I won't tell. So that's just basically throwing up the number of iterations. So iterations took. Now comes the little bit more complicated one. Our second value is going to be some more formatting. Our minutes, followed by our seconds, followed by our milliseconds. And then I'll wrap this over because I'm running out of space, and I'm going to hit escape because I don't like the yellow stuff. But I don't normally see that because I'm looking at my keyboard, not the screen as I type.
That still cracks me up.
So elapsed time dot minutes, and then our elapsed time. This is why we use the time span. It makes it so easy to get this information out. Now, we could technically go down and display all the way to the tick level if we really wanted to, but I won't here. So this will give us our first line. This is just going to tell us how many iterations we ran through and how long it took. Our next line is going to display our min and max values. So do a little new line in there as well. Hey, that yellow box is back. So, all right, that takes care of that line. We want to look at our distributions and see how those are panning out. Just a lot of formatting stuff. So we're going to look at our 0 to 0.1. Now this is, again, potentially in the millions, depending on how many iterations you roll through. And we just duplicate this 9 more times. Don't worry, the second part of this series, when we actually get into the algorithms, will be more talking.
It's all good, Lee.
I'm just
You
self-conscious.
always worry so much. No, man.
I'm saving my voice, that's it.
That's right. We've got a lot to do.
Well, what we were talking about it earlier is almost probably close to 60 hours worth of content to go now.
Don't scare anyone that's
sorry.
watching this.
Sorry. No, it's actually
Like me?
60 minutes worth.
Like me? I'm just thinking about, well, it's going to be very busy.
You said make them lots of content. That's what I did.
Yeah, we want them to see everything that's going on here.
Well, luckily they don't see all the behind the scenes frustration of me yelling and screaming and stuff. Of course, usually just a little tip for those. Make sure everything's right before you duplicate things a dozen more times. All right. So that takes care of that. Now we need to figure out our average. So I'm going to take, actually I don't have to cast that because I think I made my sum a double this time around. Yes, I did. So I can just take our sum, divide it by our iterations, but I do have to cast that to a double or I'll lose precision. There's that iterations again.
You just love that word.
All right, so now we've got that. Now I had a lot more as far as statistics in here. I at one point had median. I was calculating the probability of evens and all kinds of crazy stuff, and it was getting difficult to troubleshoot, so I wussed out. There are, like I said, with random number generation, it is a very huge topic, and some people take it incredibly seriously. There are testing suites that you can run your number generators against to get an entire battery of results to see how well or how good of a generator you've come up with. There are services that you can send off sequences of numbers that you've generated for them to generate the test for you. So apparently, where it seems to be a really big industry is in the online gambling sites. So they will come up with these truly random number generators, send them off to these services, pay them to do all these tests, and then come back with reports on how well their generators run.
That's very interesting.
It was, and
Makes
apparently,
sense, though. I mean,
yeah. Well, also that in your cryptography type stuff, if you're trying to do some hardcore encryption and stuff,
hmm
and you're generating these numbers, you want to know how well that's going to stack up against other different algorithms.
right.
So if you're investing heavy in that, you want to send off sequences of these numbers, and you're literally sending off files that have tens of millions of numbers
hmm
for them run through. And one of the sites that I said it takes like 3 or 4 weeks to run all the tests on them. So it's a serious industry. People have written thesis papers on the entire topic, and apparently there are several people that are employed at doing nothing but writing algorithms. All right, so that's all built. That seems to have everything in place. So why don't we call it at this video, and we'll come back and we'll play with it and see how well it works.
Okay. Well, that's going to bring this quick implementation of a testing framework to a close. Thanks a lot, everyone.